this chapter, we're going to explore factoring. In this lesson, we will be applying factoring to solving quadratic equations.
Okay, so now we're going to take all the work that we've been doing over the last little while here with factoring, kind of take it to its next logical step here. We're going to start to use it to solve equations, and that really is ultimately our goal, is to be able to solve equations of different types here. Okay, now the process is pretty straightforward. What we're going to do is we're always going to move everything over. When you've got an equation, and bear in mind this has got to be something that has the equal sign in it, okay? Oops, wrong way. It's got to have the equal sign in it. And what we're going to do is we're always going to move everything over to one side of the equal sign so that it's equal to 0. And I'll explain the significance of that in just a moment here, but it's got to be equal to 0. Then what we're going to do is we're going to look for any greatest common factors if possible, anything that's shared amongst all of us, take that out. Then we're going to factor it normally, okay? Just what we've been doing the last several lessons here. Then what we do is we set each factor equal to 0 and solve for x. Now, I want to talk about what's going on right here and why this works here, okay? So let's talk about setting things equal to 0 and what that means here. Let's say that I've got two factors multiplied together, and let's say that they equal 2. Well, okay, what do you know about A? A could be anything. Okay. A could be absolutely any number you want here, as long as B is 2 over A. So A could equal anything provided B was 2 divided by A. And that would work. You would multiply those together, you would get 2, okay? So, yeah, now let's not get all weird about that, because if someone's going to say, well, what if A was 0? Yeah, okay, I get it. It can't be equal to 0. But anyway, you get the idea. A times B equal to 2. Okay, A can be anything as long as B is 2 over A. But even if B is 2 over A, whatever A is, every value of A that you could choose is going to give you a different value of B. So there's not enough information there to figure out exactly what A and B are supposed to be here. However, what if A multiplied by B was equal to 0? Now think about that. A could be anything. A could be anything. However, regardless of what A is, if A isn't 0, then B must be 0. Okay, if A is 10, B has to be 0. If A is 1, B has to be 0. Okay, so if I allow A to be kind of whatever random number it wants to be, then I am restricting B to that number here. However, if A equals 0, then B could be anything. So I've got two possibilities here. Either A is equal to 0, in which case the whole thing goes to 0, it doesn't really matter what happens to B, or B equals 0 and it doesn't really matter what happens to A. Okay? Now over here in this first one, if A is anything, B is 2 over A, just like if B is anything, A has got to be 2 over B. Okay? But there's no specific, or there's no one specific value that's coming out of that. Here, yes, there is. At least one of these two terms has got to be equal to 0, and it's that idea, okay, that we're going to utilize as we go through and start solving these equations. And you'll see that pop out almost immediately. All right, so let's take a look at a question right here where we're being asked to solve for the roots of the equation, which basically means just find the solutions. Notice that this equation is already factored. Everything is on one side. It is already equal to 0. I have got x minus 3 multiplied by x plus 4 equaling 0. I have got two factors. This is like the A and the B that I was just talking about. Okay? Now, when I multiply this by this to get 0, one of two things is going on here. Either the x minus 3 is equal to 0 and I don't care about x plus 4, or x plus 4 is equal to 0 and I don't care what happens to x minus 3. Now, if this is true, then x is equal to positive 3. Now watch what happens. If I plug positive 3 into this expression, 3 minus 3 is 0. Now over here, 3 plus 4 is 7. I don't really care about that. If this one goes to 0, 0 multiplied by 7 is equal to 0. Yeah, so 3 works. Even though it makes this one 7, it doesn't matter. It made this one equal to 0. Now, x plus 4 equal to 0. solve for x by subtracting 4 from both sides, you get negative 4. If x is equal to negative 4 plus 4 is 0. Now here, negative 4 minus 3 is negative 7, but so what? Negative 7 multiplied by 0 is 0. Okay? As long as one of those factors goes to 0, that's all I need. So here are the two possible solutions to this equation. Now look at this next question right here. They're trying to mess with us a little bit. It is already factored, which is really, really exciting here. However, it's equal to 12. Well, that doesn't do it. Equaling 12 doesn't do it. Because remember, I can pick my first term to be anything. This one is simply going to be 12 divided by that. Okay, well that doesn't give me a specific value. That gives me like an infinite number of combinations. So here's what I got to do. I got to move that 12 over. But if this is written like this, that's not going to help me much here. So I'm going to expand this out. This will get me x squared plus 3x plus 2x plus 6 equals 12. Now let's bring the 12 over and group together like terms. So I'm going to get x squared plus 5x minus 6 is equal to 0. Okay, because I subtracted 12 from both sides here. Now, I am looking to factor this because I've got everything over on one side. It's equal to 0. I want to split this now up into two factors here. And my two numbers that have a product of negative 6 and a sum of positive 5, that is going to be negative 1 and positive 6. Okay, now I've factored it. I've got two factors multiplied together. The product is 0. So either it's the first one going to 0. So either x minus 1 is the 0, and then I don't care what happens to the x plus 6. Or x plus 6 is going to 0, and I don't care what happens to the x minus 1. In which case, bring the 1 over. So if x is equal to 1, if I let x here go to 1, 1 minus 1 is 0. Now granted, 1 plus 6 is 7, but 0 times 7 is still 0. So it doesn't matter that this went to 7. Just like over here, if I bring that 6 over, I get negative 6. Plugging that in, it gets me 0 here. It gets me negative 7 here, but again, that doesn't matter. As long as one of those factors goes to 0, the whole thing goes to 0. And those are two specific values I can use. As opposed to going up here, and I know some people try to set this equal to like 3 and 4 and solve for x and make that work, and it just doesn't. It just falls apart here. If this equals anything other than 0, there's too many options to make this solvable. Okay, let's take a look at another one. This one's a little bit simpler here. Now everything is over to one side, which is perfect. That's exactly where I wanted it. So all I really got to do is factor this, and all I can do here is pull out the common x. But the reason this question here is because of this guy by itself here. I've got two factors multiplied together. Most of the time people see the x minus 5 and they realize, okay, I can set the x minus 5 equal to 0. What a lot of people miss at this point here is because this doesn't look like a binomial factor, they forget that it is a factor here all on its own. X all on its lonesome here could be equal to 0. And if x is 0, 0 multiplied by, well, what would ultimately become negative 5, because 0 minus 5 would be negative 5. 0 multiplied by negative 5 is still 0. That works. If you try to solve for x there by bringing the 5 over, you get x is equal to positive 5, in which case this is the factor that goes to 0. This one would stay at 5, but again, the product is still 0. That's all you need. Okay, let's keep going. What do we got here? X squared minus x equals 6. Okay, so first rule, we're going to bring everything over to one side. So we're going to subtract the 6 from both sides. Now, I want to factor that. So thinking of factors of 6, negative 6, that differ by negative 1. And I'm suspecting that's going to be negative 3 and 2. Let's just take a quick look here. Positive 2, yeah, negative 1, and there's my negative 6. Good. Two factors multiplied together equals 0. So either the first factor is the one that goes to 0, or the second factor is the one that goes to 0. If it's the first one, then x would have to be equal to positive 3, which makes that first factor 0, makes this one 5, but so what? And if we do it in this case here, we were going to get x is equal to negative 2. If x is equal to negative 2, that makes this factor 0, and this factor would go to negative 5. But again, it doesn't matter. as long as one of those factors goes to 0. So there's two possibilities. Either this is the 0 or this is the 0, and this is what would happen in both cases. For this one right here, same thing. Just going to bring everything over to one side. So I'm going to add the 4x to both sides and subtract the 21. So it's equal to 0. Again, I'm looking for factors here, so x and x here. I'm looking for factors of negative 21 that differ by 4. This is going to be 7 and 3. I mean, those are my factors of 21. But to get the positive 4 here, this would have to be positive 7 and negative 3. Now, my product there is equaling to 0, so that's got to be either x minus 3 is equal to 0 or the x plus 7 is going to 0. In which case, x could be equal to positive 3. Granted, that means this one goes to 10, but it doesn't matter because that would make this one go to 0, so the whole thing goes to 0. Or x is equal to negative 7, in which case this one goes to 0, this one goes to negative 10, but it doesn't matter because the product is still going to be 0. Over here, same sort of problem. Okay, got to bring over those two terms, the 9x and the 5. And now we're going to factor. Now this one's a little bit more difficult to factor, and I know if you're still kind of working on factoring, some of this is going to slow you down a little bit here, but 2x squared has got to break down into 2x and x. It's the only way that's going to break down. Factors of 5 are only going to break down into 5 and 1 because 5 is prime. Now bear in mind my middle term here is going to be a sum of 9. Notice if I multiply 5 by 2, I can get 10. So I'm going to put a 5 back here. 2x times 5 is going to give me 10x. And as long as I have like a negative 10 and I add 1x there, I'm going to get that negative 9 popping out. So right here, here's my negative 10, my positive 1, gets me the negative 9 in the middle. Now, either 2x plus 1 is equal to 0 or x minus 5 is equal to 0. It's the first time we've done a question like this where there's been a coefficient in front of the x here. First thing you're going to do is bring over the 1. So x would equal 2x would equal negative 1. And then if you divide by 2, we get x is equal to negative 1/2. Now, as long as x is negative 1/2, this first term is going to go to the 0. Now, in this case right here, that's going to create negative 5/2, which is, what is that, negative 11 over 2. That, again, it doesn't matter what that other factor is equal to as long as one of them goes to 0. And in this case, that would be the first one. Here, though, if we bring the 5 over, we get x is equal to positive 5. Okay, we're going to see some balancing there. Again, this is going to go to 0. It doesn't matter that this goes to 11. This goes to 0. The whole answer here is going to go to 0. Okay, let's keep going. Bring stuff over. So 3x squared minus 11x minus 4 is equal to 0. All right, well, the 3x squared, that's easy to break up. That's going to be 3x and x. And this is actually really similar to the previous question. 4 is going to break down into either 1 and 4 or 2 and 2. However, I know that if I multiply 3 by 4, I'm going to get 12, which is really, really close to that 11 there. So I'm going to put the 4 here, and I'm going to make it negative 4. So that when I multiply 3 by negative 4, I'm going to get negative 12, and I will add 1 to that. Now that's going to give me the negative 11. Now I'm just going to double check that I'm going to get the negative 4 there. 1 times negative 4 is in fact negative 4. So that's my correct factoring. Okay, basically I'm just guessing and checking as I go. So now either 3x plus 1 is equal to 0 or x minus 4 is equal to 0. As long as one of these goes to 0, we're okay. So bring the 1 over, changing the sign, and then divide by the 3 in front, so negative 1/3. Okay, bear in mind, anytime you move, if you're moving a term to one side of the equation, or sorry, to the other side of the equations, or the equal sign there, it doesn't really matter which direction, it's going to switch signs. So anything that's positive on the left becomes negative on the right and vice versa. Here, if I want to get the x by itself, I simply got to move the 4 over, and so x would equal positive 4. When I move that negative 4 to the other side, it becomes positive. So that's going to force the second factor here to become 0. Doesn't matter what it does to the first one. Okay, this question right here it's very tempting for us at this point here to want to try to cancel the x's, like to cancel the 3 and cancel the x's here. And actually, that does work to a bit of a degree. However, as soon as you cancel the x's, you're going to lose a solution here. As soon as you see that this is quadratic, the smartest thing that you can do here is bring everything to one side, just like we've been doing over and over again. Now, take out the common factor, 3x, and I'm going to be left with x minus 2. Now, I know that this is how I'm going to factor here because I've only got 2 terms. Okay, this isn't a trinomial. We've been factoring a bunch of trinomials, and it doesn't work like that. If you've got a binomial there, I can't look at the last term, look for the product and how they add together and so on and so forth. I'm just going to take out what's common. So now in this case here, I've got 2 factors here. Either 3x is going to 0 or x minus 2 is going to 0. Okay. And if this is true, divide by 3, we get either x is equal to 0, in which case this goes to 0, but this one doesn't. Doesn't matter. Or if I bring that 2 over, I get x is equal to positive 2. Now positive 2 would force this to go to 0. Again, it doesn't matter what it does to this one. So my 2 solutions here are going to be 0 and 2. All right, now a question like this. Okay, I would advise you to make this one pretty. Right now it's kind of ugly. It's got that fraction in the front here. So let's multiply everything through by 4. Let's just deal with that fraction. If you multiply everything by 4, 4 times a quarter is 1, and we just get left with x squared. 4 times negative 5x is negative 20x. 4 times 0 is just 0. So everything is still on the left-hand side, and it's still equal to 0. But now it's a lot easier to work with. I've only got 2 terms here. So I'm just going to factor out the common x. And now I've got 2 factors here, so either x is all on its own is equal to 0, or x minus 20 is equal to 0. Now, x being equal to 0 is a solution already. I don't have to do anything else to that. That's done, basically. Here, I just got to move the 20 over to get x could be equal to 20. So if x is either 0 or 20, that will be a solution to that equation. Okay, let's keep going. All right. 5m plus 15 is equal to 0. Now, don't get thrown off by this one here. Don't try to do something here that doesn't apply here, because it's a cruel little trick for a teacher like me to throw in something like this into the mix. This is not quadratic, okay? Now, this is just linear because there's no square here. So normally what you would do with a question like this is you would bring that 15 over. It changes signs on the other side, and then you would just divide by 5. So m is equal to negative 3. Okay, it's not quadratic. There's no square up here, so you don't do any of that weird factoring. In fact, if you really wanted to factor, the only thing that you really could do here was to take out the common 5. And then you've run into a situation which is kind of weird. You've got 2 factors here. So I set 5 equal to 0. That doesn't make any sense. Or m plus 3 is equal to 0. I mean, if you really are insistent that no, every time I do this I'm going to factor and solve, well, then that's what you got to do here. This is ridiculous. But this gives you the fact that m would be equal to negative 3. So that would work here. So either way, that would be just fine here. Okay, but yeah, don't let yourself get thrown off by the presence of this linear function in there. Okay, just bring over the 15, divide by the 5, you're good to go. All right, now 3x squared equals 12. Bring over the 12, so we get 3x squared minus 12 is equal to 0. This is quadratic, so this requires factoring. At first glance, it doesn't look like I could do anything, but at the very least, I can take out the common 3. Oh, and now all of a sudden, taking out that common 3 reveals a difference of squares inside. And remember, x squared minus 4 can be factored x minus 2, x plus 2. There's my difference of squares. Now, I've got 3 factors here, but I know 3 isn't the thing going to 0. 3 by itself isn't going to 0, so it's either x minus 2 becoming 0, or it's this factor here, x plus 2 equals 0. Now, if this is the term that's going to 0, then that only happens when x takes on a value of positive 2. Doesn't matter that this goes to 4, makes no difference. As long as this one goes to 0, it's all 0. Just like over here, if I bring that 2 over, I get x is equal to negative 2. So as long as x takes on a value of negative 2, this factor goes to 2. Sorry, this factor goes to 0, I should say. This one goes to negative 2, but it's because they're all multiplied together, the whole thing goes to 0. That's what I want. This one over here, similar sort of thing. Bring the 64 over. 4x squared minus 64 equals 0. Okay, I'll take out the common 4 first. X squared minus 16 is equal to 0. And just like the previous question here, that shows me a difference of squares. So 4 times x minus 4, x plus 4 equal to 0. And you should be always looking for that if you've got the two terms, just the two terms here. It frequently will be a difference of squares here. So now I have 3 factors on the left-hand side. Well, 4 does not go to 0, but x minus 4 could be 0. X plus 4 could be 0. Now, x minus 4 will go to 0 if x takes on a value of positive 4. So if x is positive 4, this goes to 0, this goes to 8, doesn't matter. Over here, if x takes on a value of negative 4, this term goes to 0. This term would go to negative 8, but again, it doesn't matter because as long as one of those terms is going to 0, the product will be 0. That's all we need. So I hope that little pattern is making sense. We're going to do a few more here, but I hope that you're starting to get like more and more confident with that. With this one right here, we're kind of going back to something we looked at with like the second question that we did here. Bear in mind that the result here is not equal to 0, but this is in factored form already. Well, this question is designed to trip you up. Okay? We're expecting people to look at this and to immediately think that they need to set these equal to factors of 30, but that doesn't work. This needs to be 0 or you can't make any headway with it. So the first thing I got to do is expand this thing out. So negative 4 plus 3x minus 12 equals 30. So grouping together like terms, whoops, sorry, x squared minus x, and then if I bring the 30 over, negative 12 minus 30, negative 42 is equal to 0. I'm just going to factor this really quickly, just guessing and checking here, because I know factors of 42, that's going to be 7 and 6. Yeah, and as long as I make this negative 7, make that positive 6, I will get a negative x as a sum in the center there. So either x plus 6 is equal to 0, or x minus 7 is equal to 0, one of those two factors. They can't both work simultaneously, but I'm just looking for possible solutions. I'm just looking for like, what would have to happen to make this work? Okay, well, if x is equal to negative 6, that's a solution. That makes this whole thing goes to 0. If x is equal to positive 7, that works. It can't be simultaneously negative 6 and 7 together. Well, that's okay. It doesn't matter. As long as it's one of those numbers there, this whole thing goes to 0. Good. All right, now, what do you do when it starts to look like this? Well, you fix it. I'm going to multiply through by that common denominator of 10, and I'm going to make this pretty here. So 10 times 3/10 will be 3m squared. 10 times 11/10 is going to be negative 11/10 will be negative 11. 10 times negative 2 will be negative 20. Okay, now to factor this, just like I did before, I'm going to use some guessing and checking. I know that 3m squared can only be broken down into 3m times m. That's all it can possibly be. But now I'm going to run into some problems here because I've got a 20. So it could be 5 and 4. That's usually a pretty good go-to. Let's see if that works here. 3 times 4, if I multiply that out, is going to be 12m. It's close to 11. But if I multiply that, I'm going to get 5m, and there's no way I can make 12 and 5 go to 11. So that's not the answer. Let's just swap them. So put a 4 and a 5 here. 3 times 5 is 15. And 15 and 4 will get me negative 11 so long as this is negative 15 and I'm adding 4 to it. That works. And so now either 3m plus 4 is equal to 0 or m minus 5 is equal to 0. Either one of those will work. I've got two terms here, so to get the m by itself, I would subtract 3m from both sides, or just as long as I move, sorry, not the 3m, the 4. I'm going to move the 4 over. And when I move the 4 over, it changes signs on the other side of the equal sign. So, and then I would divide by the 3. So as long as m is equal to negative 4/3, that works. That sets the first factor equal to 0, and it doesn't matter what it does over here. Or bring the 5 over, and I get m is equal to positive 5, which makes this equal to 0. It doesn't matter what it does over here. Either one of those answers works out just fine. Okay, so we're going to take a look at another one here. Very, very similar. I'm going to multiply by 2 to get rid of the denominator. Now, I just want to make sure that you remember here, when I multiply by 2, I multiply every term by 2. Okay, including the ones on the right-hand side here. So 2 times a half is just going to be 1. So the left-hand side will be just x squared, but this will be negative 6x minus 8. Please remember to multiply everything through by that coefficient. Now, bring every term over so it's equal to 0. So x squared plus 6x plus 8 equals 0. All right, now I can factor. And this one's actually pretty straightforward because factors of 8 that add to 6, 2 and 4. So either x plus 2 is equal to 0 or x plus 4 is equal to 0, in which case x could either be negative 2 or negative 4. Okay? Either one of those solutions will make that whole expression equal to 0. Now, one more, and it's a beast. Look at that. Oh my goodness, look at that. That is horrendous. Okay, well, first of all, bring everything over so it's equal to 0. Okay, well, that's been done. It is already equal to 0. Now what I want to do is take out the common factor. Oh, and would you look at that? Look at that. X plus 5 shows up in all three of those terms. X plus 5 is common. That leaves me with x squared minus 6x plus 9 on the left-hand side there. Well, okay, well, this is perfect. So now I just have to factor this trinomial, because remember, it all has to be in factored form for this to work. So xx, factors of 9 that add to negative 6, well, it'll be negative 3, negative 3. Now, actually, look at that. These two, I know are going to be the same answer. Both of those will be x minus 3 equal to 0, which means x could be equal to 3. If x is equal to 3, the whole thing will go to 0. The other possibility is that this x plus 5 goes to 0. And when you bring the 5 over, you get x is equal to negative 5. So either one of these two would be an okay solution to this problem. Okay? Little ugly here to start off with, but once you took out that common factor, actually it cleaned up quite nicely.